Today we're going to talk about climates of the Earth. We're not going to get necessarily into the specific climates today. That's going to be another day. But today what we're going to talk about is the things that like cause climate and kind of the difference between like weather and climate and the way that the Earth moves in order that and how that affects climate and things like that. So that's what we're going to get into today. So here we go. Okay, so weather. Obviously, anything red on here is going to be highlighted, just FYI. But weather is the condition of the atmosphere in one place during a short period of time. So it's what it's doing outside. So right now, as I'm making this video, it's raining outside. So that is the weather. Okay. Climate, on the other hand, is what happens over a long period of time. So in this climate, we sit right between humid subtropical and humid continental. And so we have very humid summers, very hot, humid summers, and then we have very long, cold winters. Okay, so that's kind of our climate. The natural vegetation, this is the plant life that just naturally grows in an area. Okay, so in this area, we have like trees, for example, that naturally grow here, like oaks and maples and those. Um, but something that would not be natural would be like a palm tree. So if you see somebody's house with a palm tree in it, that was not natural. That was put there by man. So natural vegetation is just whatever grows naturally in an area. And then the greenhouse effect is when the Earth's atmosphere traps the sun's warmth. And I'm going to get more into the greenhouse effect here on the next slide. Okay, so for those of you who don't know what a greenhouse is, it's basically a structure that is covered in plastic. It's like opaque plastic. And then what happens is that the sun rays hit it and then they can't escape. So it becomes very warm inside of a greenhouse. And so that's basically what the greenhouse effect is with the Earth. So the idea is that there's pollution that is keeping some of the sun's rays from bouncing out. So like this is what they're supposed to do. Like so, some come in to the Earth, and then some bounce off the atmosphere. Some come all the way to the Earth and bounce off. But the greenhouse effect is a layer of pollution in the air, and it's not letting some of those rays bounce off. Okay, and so they bounce around, and it makes the Earth hotter. Okay, and so this leads to what's called global warming. Okay, so global warming is a rise in CO2 levels that causes a rise in global temperatures. Okay, now there is global warming. It is indisputable fact that there is global warming, but there's a debate on what causes it. The big debate of global warming is it man-made, like we see in this graphic here, or is it naturally occurring? So, because the Earth cools and warms all the time, and we are actually in the middle of an ice age. Okay, for 2.6 million years, there's been an ice age. It's called the Quaternary, and it's been going on, like I said, for 2.6 million years. And so we are in what's called a warming period. But the question is that because of the ice age is starting to end, or is it because of our pollution? Okay, there's probably, in all honesty, some kind of combination of the two. So this right here, just a cute comic I saw, says, "Good news, at the current rate of global warming, we should be able to swim over there and eat them in under 5 years." So the sharks will have a nice meal as global warming happens. And then this is a very famous picture of a polar bear who's stuck on a melting glacier and or iceberg, I guess in this case. But anyway, it's a very very famous picture that basically displays global warming and how it's impacting the Earth. The thing is polar bears, to help make you feel better about polar bears actually have their population has grown. So in the 1950s, it was around 5,000. Today, it's around 25,000. Okay, so this is there's a lot of polar bears. They're actually thriving right now, so that's a good thing. So, okay. So the Earth's rotation. So the Earth sits on an axis, which is an imaginary line that goes from pole to pole. It goes right through the middle of the Earth, from pole to pole. Okay, so this right here, if it was going through the middle of the Earth, would be the axis. Okay, um, so it spins on the axis, and then it tilts. So it tilts up to 23 and a half degrees. Okay, so whenever it's at 23 and a half degrees, that's called a solstice. Okay, so this happens in the winter and the summer. Okay, so right now, this would be the summer solstice in this picture here for us. Okay, it would be the winter solstice for like Australia because the earth is pointed towards the sun. Okay, you see, because right over here, that's where the sun is. Okay, and so that gives us our seasons. So when it's pointed the other way, when it's pointed like this way, 23 and a half degrees, that's the winter solstice. So that's the next solstice that we're going to see, okay, is the winter solstice. That's December 21st. June 21st is the summer solstice. Okay, and then when it's upright, that's called an equinox. Okay, so when it's upright, that happens in the fall and in the spring. Okay, so that shows the change in that. So the next equinox is coming up in this month in September the 21st. Okay, and then the Earth obviously orbits around the sun. Okay, so the Earth uh, orbits and tilts as it orbits around. Okay. So rotation. So rotation occurs every 24 hours, and this is what causes daylight and darkness. And then a revolution is an entire trip around the sun. So that's 365 in about a quarter days. So this is why every 4 years, like this year we had, this year is a leap year, so we had an extra day because it's just a little bit over 365 days. Um, and then the equinox, like I said, is when the sun's direct rays are over the equator. So when the axis is fully up and down. So in the spring, that's March 21st. In the fall, it's September 23rd. Okay, I got the date wrong earlier. So September 23rd. That's the next one coming up. So this right here shows the equinox. Okay, so everything is even during an equinox. So the sun is directly hitting onto the equator. Okay, so this right here would be the equinox. Okay, so the summer solstice is June 21st, and this is when the sun's rays strike 23 and a half degrees north. So that's the Tropic of Cancer directly. Okay, so where we saw here, it was it's hitting the equator directly. During the summer solstice, you can see it's directly hitting. I'm sorry, this is the winter solstice right here. But during the summer solstice, it would be directly hitting the Tropic of Cancer. Okay, so the winter solstice, which is December 21st, is when it hits the Tropic of Capricorn. Okay, so you're going to need to know the difference between the Tropic of Cancer and Tropic of Capricorn. So the Tropic of Cancer is in the north, Tropic of Capricorn is in the south. Okay, and so this right here is showing the winter solstice. Okay, so you can see how the earth is tilted away. So this is going to happen December 21st, where the sun's rays are directly hitting the Tropic of Capricorn. Okay, right here. Okay, and so that makes it wintertime up here in the northern hemisphere and summertime down here in the southern hemisphere. Okay, so like Australia, it's summertime when it's winter here. Okay, so the poles. So the North Pole, the sun never sets from about March 20th to September 23rd in the North Pole. So right now they're in a period of sun. In the South Pole, the sun never sets from September 23rd to about March 20th, is what that should say. Okay, and so they go opposite. Okay, they go opposite of each other. And so this is called what is called midnight sun. Okay, it lasts for about 6 months, and that's while the pole is tilted away, no sunlight hits at all. Okay, so no sunlight is hitting in this one. This would be like the summer solstice here for us. No light is hitting the South Pole. Okay. So this right here is a picture the photographer took same time every day on the North Pole, and this is what it looked like during the midnight sun. So during when the sun was up for 24 hours for 6 months. Okay, so 5 factors that influence climate. So you're going to need to highlight each of these factors. Okay, so one is latitude. Okay, so that's basically how far away are you from the equator. So the farther away, the colder your climate's going to be. Okay, so we have what are called the low latitudes, and these are the ones. This is really what we call the tropics. Okay, so they always are receiving direct rays of the sun. Okay, all year round. So that's the area between the Tropic of Cancer and the Tropic of Capricorn. They're very, very warm climates. So that's this area right here, this band. That's the low latitudes because they're closest to zero. Okay, and then the middle latitudes, that's 23.5 degrees to 66.5 in the north, and then 23.5 to 66.5 in the south. So this right here, this area, see where it says Arctic Circle? So everything below that, between Tropic of Cancer and the Arctic Circle, this is the middle latitude, so that's where we're at. And then this is right here, the middle latitudes. And then the high latitudes are the polar areas. So this is anything above the Arctic Circle here, and then anything below the Antarctic Circle here. Okay, so that these are the high latitudes. High latitudes are very, very cold. Okay, so this right here shows you, again, the different latitudes. Okay, so it's going to be much, much warmer in the low latitudes. All right, next thing is elevation. So elevation refers to how high you are above sea level. Okay, so as you go up, the atmosphere gets thinner. Okay, so as altitude increases. So every about 1,000 feet, the temperature drops about 3.5 degrees Fahrenheit. Okay, so every time you go up 1,000 feet, it gets colder. Next one is wind patterns. So this one definitely contributes to what kind of climate you have, and especially in regards to how much rain you get. Okay, so there's 2 types of winds. So there's prevailing winds, and these are winds that blow in fairly constant patterns. This is mostly what we see as prevailing winds here. So there's 2 types of prevailing winds. You have the trade winds, which blows toward the equator from 30 degrees north to 30 degrees south. Okay, so they blow like, they're usually colder because they're blowing from a colder area into a warmer area. And then you have the westerlies. That's a type of prevailing wind in the belts between 30 degrees north and 60 degrees north latitude, or 30-60 south. Okay, so this is the westerlies, is the kind of wind we usually see. And then you have the doldrums. So doldrums are mostly windless areas, and those are usually near the equator. And a lot of that has to do with the way the trade winds move, because what they'll do is they'll hit and then they'll die when they go towards the equator. Okay, so this right here shows you the trade winds. You could see they're moving in, and so a lot of that air, it'll hit and then it'll rise, and then you don't get a whole lot of wind along the equator. You have the dry sinking air here, and this is where we live, is in the westerlies. Okay, and the polar easterlies, that's where you're getting wind coming from the poles down south, and that's whenever that happens every once in a while in our area, where these winds will come down south, and we'll get like major wind chills coming out of that. Okay, so that's when it gets like really, really cold in the winter, is when those polar easterlies push the westerlies basically out of the way. Okay, ocean currents. So ocean currents are currents. There's cold and warm, basically like rivers in the ocean. Okay, so if you've ever seen Finding Nemo, they get on that ocean current and then they go to Australia. Spoiler alert, they do that. So that would be an example of an ocean current. So ocean currents, the warm ocean currents coming from the equator. Okay, so obviously the water's going to be warmer here. So what's going to happen is it goes like it goes counterclockwise in the north, and then it goes clockwise in the north, and then counterclockwise in the south. Okay, so um, the what'll happen is the currents will push north, and then they'll get cold up here, and then they'll push back south, and then they'll get warm down here, and then they'll push, so they just kind of go back around. So you can see a lot of these are making circles. Okay, so it's the opposite. They go counterclockwise in the south, where it pushes south, and then it gets cold down here, and then that pushes north. Okay, so it kind of depends on where you live, what kind of water you're getting. The warmer the water, the warmer the climate. Okay. Landforms. So landforms are going to impact uh, climate in a couple different ways. So one way is the orographic effect. So basically, what happens with that is the winds blow over an ocean, and then they meet a mountain. This is what happens on our west coast, on what's called the windward side. So the windward side is the side that faces the ocean. And so that wind, when it hits the mountains, gets pushed up because it's got nowhere else to go. So it goes up. And so as these winds rise and cool, they drop moisture. So the air goes up into the clouds and then drops moisture. So uh, climate on the windward side is going to be very, very wet. So think of like Seattle, Portland, those different cities that are very, very wet, and that's because of the orographic effect. Because the wind is hitting the mountains that's just to the east of them, and then it's dropping rain on them as a result. Okay. Now on the leeward side, so on the opposite side, all that rain has kind of gotten out of those clouds on the windward side, and so on the leeward side, it's usually very dry. This is called the rain shadow, and I'm going to show you some pictures here that display what that means. Okay, so this right here, so you have this would be like an ocean here. So the wind comes in and it hits the mountains, and then it goes up, and all that water that's in there kind of gathers in the clouds here, and then it drops it. Okay, so this side is very wet, and then winds that come over across usually have lost a lot of that water. So this is why we get deserts on the opposite side. Okay, and I'll show you this. This is another example. So this is actually the Sierra Nevada. So this is in California. This is exactly what happens. So the wind comes off the Pacific, it hits the mountain range, the wind goes up, all the water comes off in this moist area here, and then the winds that come over don't have a whole lot of water in it. So this area over on this side, on the eastern side of the Sierra Nevada, is very, very arid. All right, that's all I got for you guys. I hope you guys all have a wonderful day. Don't forget to do your processor.